So I was talking about some of the file formats when I was discussing Hadoop or Hive in that case. Uh, there are file formats that we can easily read or we can easily scan, much like text or CSV files, but they are not good fit for the Hadoop ecosystem. The reason being their compression is not very good, their schema handling is not perfect. So those are the reasons why that those are the reasons these files are not widely used. So whenever we talk of keeping the data in Hadoop, it's mostly Parquet ORC or sometimes Avro. Right. So these different file formats have different use cases. So keeping aside Avro and Parquet for the moment, let's talk about ORC a bit since we're discussing the Hive functionalities or the Hive operations. So to summarize one thing, ORC is the best fit for Hive. ORC is the file format that works well with the Hive because of the thing called the vectorization. By default, it is enabled only for ORC. I mean, we can enable also for Parquet and Avro. They are also good file format with compression. But the thing is, Hive actually has this by default enabled for ORC files only. This vectorization. Now, what is this vectorization? So whenever we try to read a data or table using a select star command, so any table usually that tries to scan the data for each and every row. Okay, but with the vectorization enabled, what happens if we try to fire up a select star query? In that case, it will try to read a block of data instead of like each and every row. So that block will contain multiple rows. So it's much easier and much faster in a way. Suppose I have like 1,000 rows in a table. Okay, and if the vectorization is not enabled, and if I try to run a select star query, in that case it will try to read the data in 1,000 iterations, right? But suppose if the vectorization is enabled and each and every block it contains say like 20 records, and obviously the iteration will be less. In less amount of time the data will be fetched. So this is the beauty of vectorization that comes by default with ORC. Now, apart from that, ORC also helps in a different functionality. So I was talking about the immutability of Hive and Hadoop. You place a file over there, you can read the file, but the fact of the matter is you cannot edit the file. You cannot modify the file, or there is no ACID operations as such supported in the Hive tables. We cannot update any record, we cannot upsert or delete any record from Hive table, right? But that jinx is kind of broken from the Hive 3 later versions, that is the Hive 3.2. Okay, there are some certain attributes that needs to be enabled while make Hive support the ACID operations, right? But the first and foremost thing that needs to be done is the table has to be bucketed. Now, what is bucketing? Obviously, I have covered that in the previous session. Also, at the same time, the file formats needs to be ORC. Then only this ACID operation will be allowed in Hive table. Along with that, these are the properties that needs to be set in order to make the hive able to carry out all the ACID transformation like edit, update, delete, or anything. Mostly update and delete record. All right. So you might be saying that the Hive enforced bucketing is true. So that is the reason that table needs to be bucketed. Okay. We can partition the data as well if we want, but that's something which is kind of an optional thing. Not necessarily we have to keep it. Not necessarily we have to keep it. Okay, apart from that, we do have to set the transaction manager as with the DV transaction manager, and the concurrency also has to be true. So these, after setting these properties or enabling these Hive configurations, only the ACID transformations or the any edit of the record would be possible. Okay. And keep in mind, whenever you're creating the table that needs to perform any kind of ACID operation, in that case we have to put this table properties, that is transaction equals to true. Only after that your Hive will be able to carry out the update and edit, update, upsert, or delete row operations. Okay. so this is about so this is about the functionality of ORC files that comes with Hive, and that is the reason ORC is the best fit for Hive. It kinds of like allows Hive to do certain other things that is not kind of expected from other file formats. But it's not like that the other file formats such as Avro and Parquet, like they are not good at all. Okay, we should only be focusing on ORC. So these different file formats have different use cases, have different scenarios where they should be used. For example, Parquet file format, it is best fit for Spark, be it Spark Scala or PySpark, whenever you are using a Parquet format, this vectorization is then by default enabled over there. Okay, Spark also does this vectorization, and by default it is enabled for Spark only. Sorry, by default it's enabled for Parquet only. Okay, along with that, if you try to save the data without specifying any file format, be it in Hive or Hadoop or S3 for that matter, then every time Spark will try to Spark will try to write the data into Parquet format only. That's the default file format that Spark understands. Okay, so in terms of compression, if you look at the chart, you can see that uh, the ORC is best for the compression. So ORC will take the least amount of space compared to Parquet and Avro. But the thing is, there is one other thing is the splittability. If the files are splittable, in that case, it's much easier to read the data in chunks. It's much easier to parallelize the data. So in that case, also ORC is very good. Okay, but with the vectorization thing, also along with the keeping the partition, whereas the number of partition will generate the number of files. For in those cases, only Parquet is the good fit. Okay, there's another segment you're saying that these two are column and this one is row. So what is column and what is row? This thing I'll be discussing later on. But if you look at the overall picture, so Avro is something that is good with the schema evolution, and also it works well where my application is a real-time application, be it near real time or be it an absolute real time, like a streaming data ingestion from Kafka or anything. Okay, so that's where Avro comes best, because the thing is, writing data in Avro format is much faster than Parquet and ORC. So this has something to do with the row-based file format thing. Okay, along with that, there is another thing that stands out, that where Avro stands out is the schema evolution. So in the real-time data scenario, in real-time ingestion, what happens is that the schema can be changed at any time, and we won't be able to know that. So to handle that, the Avro schema registry works best fit for this. So Avro schema registry will automatically understand the schema has been evolved or modified, and accordingly it will change the Avro schema. And one more thing, when you try to write data in Avro format, what happens along with the file, that is .avro file, there will be one more file generated, which would be .avsc. So when you try to write a file using Spark, suppose say spark.read.format avro.save into a path, so you will see in that path there will be avsc file, along with that there will be .avro data. So .avro will contain the data, that is binary format data. You cannot read it. It's not human readable. But the .avsc file, that will contain the schema, and you can see the schema. You can understand that how it looks like. I mean the data structure. Okay. So when I talk about Avro schema, so this is how basically it looks like. If you look over here, there's this avsc file .book.avsc, and over here the schema is specified as the name and the data type. So first one is the name, column name, and the its data type is string. Second column name is ID, and the data type is integer, which can also handle null. And the third one is the category. So this is the column name, and this is the column type or the data type, that is a string. Right, and it can also handle null. So this is the speciality of Avro, that it kinds of separates the schema, and it gives a copy. So anytime if anyone wants to update or modify the schema, then simply this avsc file needs to be updated, and accordingly the schema will be modified. Okay, so now talking about the other section, there was a segment, right? For Avro, it was written row, and for Parquet and ORC, it was written column. So what does it mean? So and how does it impact? So one thing you need to understand, that whenever you're reading a data from anywhere, be it Hadoop, Hive, or using PySpark or anything, reading column format data is much easier, it's much faster and efficient than reading a row format data, right? And if I talk about writing the data, be it in Hadoop, Hive, anywhere, S3, while writing the data, it's much recommended that you write the data if you're doing a process where writing will be done more often than reading the data. In that case, you can write the data in a row-based format data, like Avro. Okay, and the reason is because for the row-based storage, what happens is data for a single row of a table is stored together in one block or one page of disk. So basically, each and every disk, if you look at this diagram, so each and every disk is having one row. Okay, so that's how the data is sequenced. So whenever you try to read the data, whenever you try to write the data, obviously one row will be written, then the second row will be written, third row will be written. It's much faster. Okay, but when you try to read the data from a columnar-based format, so what happens? Each and every column value will be in a disk. Each and every column value will be stored separately on a disk, which means the values for a given columns are stored together. Okay. So basically, what has happened? If you look at the diagram over here, this is the full table, and column one, column two, column three has 147, 258, and 36. So if you look at this diagram, one and four, the column value is sitting together. Then column value two and five, then three and six, and so on. So basically, if I try to read each and every column, then this is much faster. Okay, while writing it, it's not, because the first is the column one, column two, column three. These are being written, and then column to column three, then column to column three again for like 1 4, then 7 10, then 2 5, then 8 11, then 3 6, then 9 2, then 9 12. So basically, if I talk about each and every split, okay, so it is getting, if I talk about each and every split, and if I see the whole picture of the table, then the write is getting delayed. Okay, only this one will be written, then after this one, then after this one, then after this one. But instead, if I try to write each and every row like 1 2 3 4 5 6 7 8 9, this is much faster, right? And this is the reason why writing the data using a row based file format is an efficient way of writing the data. So that is why in real time, where the writing is happening more often, each and every second, the data is being dumped into some form of data lake. Okay, so in that case, what happens is that we should be using Avro format data. We should be using an Avro schema to make the data able to evolve. For the make the data be ready for the schema evaluation. At the same time, the writing is much faster. It won't have to depend like each and every column. It will write and then group it and then store it in the disk. Okay, so that is the reason row-based file format is best use case, best fit for writing the data, especially for the streaming one. And if I'm using column-based storage, if I'm using column-based file format, then what's happening? Suppose I'm trying to, there are like 100 columns, and if I'm trying to select only like 10 columns out of it, in that case, there is no need to scan all the rows, right? I can simply, or my table can simply scan the only required 10 columns that it needs. So over here, since the column-based file format, you can see the columns are grouply stored. So in that case, if I just want to say read the column one and column two from split one, it can easily happen, right? It won't try to even get from the column three. Okay, so that is the speciality for the column-based file format and how it helps while reading the file from any data lake, be it like Hadoop, Hive, S3, or anything. So Parquet and ORC, these two are column-based file formats. So while reading the data from any of these two file formats is much efficient than reading the data from an row-based file format like Avro, right? So this is the reason. This is the reason why for Spark, batch operations and Hive queries, we use Parquet or ORC, which are the column-based file formats. And for streaming data ingestion, suppose for Kafka or anything, we use the Avro schema registry URL or the Avro's file format, because over there the writing would be much more efficient.